Hello, this is Audrey Munger, and this is my first lab for Physics 2212 on charged tapes. In this experiment, the main goals were to find the amount of excess charge on a piece of charged clear tape and observe the interactions between two charged pieces. To make my tapes charged, I took a first piece of tape and stuck it flat against a table, and then took a second piece of tape and stuck it along the first piece, and then quickly ripped it up off the table. I could tell it had worked because the tape moved towards my hand afterwards. For the purposes of the calculations of this lab, it can be assumed both pieces of tape have equal charge, and for the first model, it will be just 1 point charge. So in this lab, we're going to be calculating two forces. So there are two important physics concepts, one for each force. The first is Newton's second law, which calculates the force of gravity, and the second is Coulomb's law, which calculates the electric force. I also included this diagram of the electric field because it gives some background information on how positive and negative forces attract and repel each other. Okay, so now going over some starting conditions for the tape. The tape's length was 0.2 meters, and the tape width was about 0.02 meters, or 2 centimeters. The tape's mass was 0.2 grams, and the distance between tapes while they were floating and charged was 0.025 meters, or 2.5 centimeters. Once I had confirmed that my tapes were charged correctly, some starting observations I had were the two pieces of charged tapes repelled each other, the tape moved towards my hand while it was hanging, the tape was attracted towards a neutral object, which I used a book, and the tape attracted the pen. Based on all these observations, I can conclude the tape was positively charged. Using the mass of the tape I calculated, I was able to calculate the gravitational force on the tape. Because the tape was in equilibrium when it was floating, we know that the magnitude of the electric force must be the same as the gravitational force. Using the electric force and the distance between the tapes, I was able to solve for Q, the charge. By knowing the charge of an electron and the charge of the tape, we can solve for how many electrons the tape is deficient for, which there's a typo at the end, it should say electrons. The first computational model represents the charge on the tape when the entire piece of tape is calculated as a point charge. On the right, I show a snippet of my code, and on the left is the diagram that appears with the model. Here is the computational model part 2, where the charge on the tape is modeled as a line of charge rather than a point charge. Now looking at the coding questions, the first asks about the magnitude of charge on the piece of tape when it's calculated as a single point charge. My charge from my computational model was 5.48 e to the negative 8 coulombs. The second question asks the magnitude of the electric charge on the second computational model with the line of charges. My model got 3.73 e to the negative 2 coulombs. Some assumptions I had to make for my computational model was that the charge was spread completely evenly over the piece of tape, meaning there wasn't one side of the tape that had more charge than the other, and that there are no other forces acting on the tape other than gravity and its electric charge. The what-if question asks what would happen if protons and electrons had reversed charges, meaning protons were negative and electrons were positive. This would not change anything because the forces would still attract each other. The why question asks to compare the estimated values of charge on the experimental models and which value of Q is more likely to be real. The point charge resulted in a smaller value of Q, however the line of charges is more accurate as the piece of charged tape is charged across its entire length.